All right, so I kind of went through and gave feedback on the ones I could give feedback on. Overall, pretty good. I will say a couple of things. None of them were perfect, like all the way through. So make sure you catch these little mistakes. The first one is that you guys overall did pretty decent on this. Don't forget, a couple mistakes is don't forget to multiply on the other side of the equal sign. So that 2x plus 1, 2x minus 1 had to get multiplied by the -4. And then when you did that and you worked it all out, the 16 squareds canceled out. Solving it, I got 11/6. Make sure you check these answers. So if you plug that back in, you don't have to plug it all the way back in to make sure that it's right. You just have to plug it back into the denominator and make sure that you're not going to get a 0 in the denominator. So like if by chance my answer here had been a 1/2, I would have ruled it out. A -1/2 or a positive 1/2. So make sure, that's the biggest thing people will forget to do. Let's say this is it has two answers, and then whether it's not multiple choice or multiple choice, people put both answers and you think that you're right, you're feeling so confident, and you're wrong because something could have given the 0 in the denominator. So just be really, really careful with stuff like that. The second one, again, overall pretty good quadratic formula. Watch your simplifying. Some of you made mistakes in just like the simplifying. Your A is 16, your B is -40, your C is 5. Plug it in, work it out, and I got to the point that I was like 40 plus and minus the square root of 1,280 over 32. That 1,280 breaks down to 16 root 5. You cannot simplify the 16 and the 32 without simplifying the 40. You can't simplify part of a sum. So all of them were divisible by 8, and then from there I got 5 plus and minus 2 root 5 over 4, which could split into 2, 5 minus 2 root 5 over 4, or 5 plus 2 root 5 over 4. This would probably be an answer that you could write on the answer sheet, or it would be multiple choice, so either of those is fine. Then came your fractional exponents. So remember, if you want to get rid of a fractional exponent, we raise it to the reciprocal. So we raise both to the 2/3. In doing so, 27 to the 2/3, the number on the bottom of the fraction becomes the index, or the front of the square root. So you'd end up with the cube root of 27 squared. And then that's 9. And then you'd get x plus 5 equals 9. And then subtract the 5 and you get x equals 4. Because the original question was a square root, so like this is really x plus 5 to the 3/5, which is the square root of x plus 5 cubed, you also have to check those. So you want to make sure that when you plug that back in, you don't get something like a negative number, that when you cube root it, it would equal a negative and the other side's positive. So these, anything with a square root in the original question, you also have to check. So fractional equations, and then anything with a square root in the original question, you have to check. Roots. This one, interesting. I think this is the one that most people made the mistakes on. You have to divide both sides by -2 before you can determine if this is an and or an or. So you divide both sides by -2 and you get the absolute value of x minus 5 is less than 5 because the sign flips because you're dividing by negative. Because it's a less than, it becomes an and statement. So the -5 goes on the other side of the equal sign. -5 is less than x minus 5, which is less than 5. Add the 5s and I get 0 is less than x, which is less than 10. That's an and statement. If it was on the number line, it would be shaded in between, and if it was in interval notation, it'd be 0 to 10.
Wait, you put the coordinates?
It's not a coordinate, it's interval notation. So you're saying from 0 to 10.
Oh, I forgot
Yeah.
that.
So just watch. I mean, the directions will tell you either you're getting in an inequality statement like this one, or you're going to put it in interval notation like this one. I will tell you, I'm going to be a little ruthless on the grading with these. Like, there's not going to be a whole lot of partial credit on something like that. This is something that you've now seen like several times. You have to make sure you check for your and or statements, okay? Then came solving your quadratic inequality. So we have to move everything to one side. When we do, I get x squared minus 5x minus 6 is greater than 0. Factor it out, solve it. You get 6 and -1. Those are your test points. Plug in something less than -1 and you get a true statement. In between -1 and 0, false statement. Right of 6 and you get a true statement. So your inequality would be x is less than -1 or x is greater than 6. Be careful, again, that's an or statement. And then your interval notation would have looked like this: -infinity to -1, union 6 to positive infinity.
I remember doing this with graphs.
Yeah. Questions on that one? All right, we're just going to get a head start on this so that tomorrow you can finish it and work on your homework in class. Again, everything you see today in P4 should be review. This is graphs of equations. So with if a point's on a graph, Okay, if the point's in the graph, then when the point is plugged in, the result would be a balanced equation. So if you get given a graph equation and it says, is it a solution? You're literally just plugging that point in. If the left side equals the right side, then it's a yes. If it's not, then it's... So this says determine if 1, 5 is the solution to y equals 4 minus the absolute value of x minus 2. So this is my x and this is my y, and I plug it in. 5 equals 4 minus absolute value of 1 minus 2. 5 equals 4 minus absolute value of 1 minus 2 becomes the absolute value of negative 1. And the absolute value of negative 1 is positive 1. 4 minus 1 and 5 equals 3. This is not a true statement. So this answer would be a no. If it was a true statement, yes. If it's not a true statement, no. Okay, then we get to x and y intercepts. So just like every graph we have done for the entire year, if I want to find an x-intercept, I'm going to plug 0 in for y. If I want to find a y-intercept, I'm going to plug 0 in for x. These should be coordinate points. So you're not giving me an x equals like that. You're giving me a number and 0 for the x-intercept, and a 0 and a number for the y-intercept. Again, you want to give that in coordinate point form. So this says find the intercepts from the graph and algebraically. So if I'm just looking at the graph, my x-intercepts are where it crosses the x-axis. So my x-intercepts would be at negative 2, 0, and 2, 0. My y-intercept would be where it crosses the y-axis. We're jumping by 4s here. This would be 4, 8. This would be 12, 16. So the y-intercept is 0, 16. That's the algebraic part. Then it says find it, I'm sorry, that's the graphing part. Then it says find it algebraically. So I'm taking y equals 16 minus 4x squared. To find my x-intercepts, I plug a 0 for y. And there's a bunch of different ways to go from here. I can either move the 4x squared over, divide by 4, square root it, just making sure I do the even root property. I could factor it, right? I could even take out a 4. Or I could do 4 plus 2x, 4 minus 2x, and then split and solve it. Negative 4 would equal 2x. X would equal negative 2. Negative 2x would equal negative 4. X would equal positive 2. Again, I could have also moved the 16, divided by 4, and then done plus and minus, and I would have gotten the same answer. So that matches that. And then for the y-intercept, I plug the 0 in for x. And I get y equals 16. And that matches that. Easy stuff, right? Yes, we've seen intercepts a lot of times. Just don't forget.